Let's get back to it. Let's get back to work. We've left important work on the table in the last year and a half because we have not been inputting and incubating and ideating, because that's what these conferences are about, is doing all of that stuff in a compressed time period outside of our normal space. That's why we do them. It's why I sponsored. This stuff is important and we have been forced to neglect it. So I'm so glad to be back doing it. Hopefully we'll be able to continue and won't have any more disruptions. Hi. Thanks for being here, all of you, for making the trip, some of you near, some of you far. I think I got somebody from Boston. Do you have anybody farther away than Boston? Was Boston our farthest away person?
Yeah, Mexico.
Okay, cool. Well, that's just due south of here. That might not actually be farther than Boston, but we will count the international boundary as an extra add-on and a free elevation. Okay, so thanks for coming. This is Reduce Technical Debt Through Better Software Package Design. I am your host, Alan C. Smith, Consulting Software Architect. For the folks here who don't know who I am, I've been an architect since 2004. I have been writing a LabVIEW code for 28 years, as long as my friend John has been, which feels like bloody forever, because it is. I've done it all, worked with partners, been a partner, did a stint at NI for 6 years, not as a fresh out of college employee, which is a really interesting experience. Back to being a consulting software architect. I can help you with your problems. I have a co-presenter. Well, I have that oh, he fell down. He fell down. Oh, sorry, no. I was told I have to have Tiny Monster up on the stage with me. I have a co-author on this paper. He's not my co-presenter today. John McBee, president of Composed Systems. I think we just have the one Composed Systems guy here. Co-wrote this with me back in 2017. We first presented this at NI Week in 2017. Why am I presenting an old topic to you guys? Right? Why am I going back to this? Well, I wanted to. I've wanted to bring this back for quite some time, and you can see why in John's presentation on System Link and Jim Kring's presentation on Dragon. In the last several years, we have been talking more and more and more in these spaces about the importance of DevOps, about the importance of delivering our software to our customers. And our customers can be the guy at the next desk who wants this piece of reuse code I just wrote, all the way up through the complete package delivered to our ultimate end customers, okay? I mean, and when we first started, when John and I first did this presentation, it was VI Package Manager. That's what we had. And VI Package Manager is an awesome tool. I love it. We had NI Package Manager was kind of the new kid on the block back in 2017. We were starting to figure out about that. And we were talking about other things sort of in the advanced spaces, but in terms of kind of the general LabVIEW community, we were just getting rolling on this stuff. But it's only exploded since then. G Central and, MGI's got a build solution now that ships with LabVIEW, and System Link, again, I mentioned, and Dragon's coming along nicely. And we're talking about Jenkins, and we're talking about GitLab, and we're talking about the whole DevOps chain of delivery. We're talking about all of these tools. Why do we have tools? We have tools to support our work. Our tools work for us, not the other way around. We have tools to support our architecture choices. Why do we do architecture? It's a Robert C. Martin quote. I love this guy. If you haven't read his work, please just go buy his books. Just do it. And then read them and digest them. We do software architecture to facilitate the development, deployment, operation, and maintenance of our software that we deliver. Okay, and you'll notice that development is just one part of all of this, okay? And we have the tools to support this notion. And I've wanted to bring this talk back for a little while because we did it the one time and then it kind of disappeared, right? There's no video of it, there's no link, there's nothing, right? I wanted to get it back out in front of the community because as we've been talking again about all of this delivery and all of these tools for delivering packages of software, well, maybe it's time to go back and talk about what's supposed to be in those packages so we can get the most benefit out of our tools. And I can't claim that I've got a lot of original thought here, because I am just a student of software development. This agile software development should be on your shelf. If it is not, just whip out your phones and go to Barnes & Noble, because I order my books from Barnes & Noble, not Amazon, and order it, have it shipped to your house, and read it. Great book. Has a whole section on package development. What goes in packages, what gets distributed, and how, okay? That's what I'm talking about today. This isn't tools. This is not a tool presentation. This is not a how-to. This is a what and a why and a planning. I'm going to draw on mostly hypothetical examples just to illustrate the point. Let's do a case study. This comes out of my time in systems engineering at NI. This is not an actual customer, okay? But this is representative of a couple of different related issues that I saw come up with a couple of my customers that I was there. That was my role, was to help people be successful with LabVIEW. So I'd get these weird problems, right? Okay, this hypothetical customer had a legacy system, something they had been hammering away on for, a decade. You know how it is. Everybody kind of, expands the system a little bit, and then they need to make a change, expand a little system, right? Okay, and they built it into an executable. And then they decided, you know what? We need to rev our instrument package. It's time. Stuff is going into obsolescence. And they wanted to do it right. They wanted to, let's make the change easy, then we'll make the easy change. That's it's not a Robert Martin quote, that's somebody else's quote, but it's a fabulous quote. And they said, let's do a hardware abstraction layer, and then we'll write all of these instruments and we'll roll them into our executable, and we can do whatever we need to do. And their build time went from 45 minutes, which is long, but not crazy, to 90 minutes. Okay. It's only 90 minutes, doesn't seem like a big deal, except that as they were developing their software, they're constantly tweaking on this, because this is the stuff they're actively working on. And so their write, build, test cycle now doubled in time. You had this big bottleneck in it, right? They couldn't cycle on this fast enough. It was a real impediment to their ability to work. It's like the old XKCD cartoon that the primary cause of sword fights in the hall is your compile time, right? Yeah. So they wanted to stop that, and so the request that came into us, again hypothetical but based on on some real stuff, was, hey, how do we pop that sucker out into a bunch of plugins, right? And then the idea here is that they would build the executable once. That would take 45 minutes, actually a little less because they'd pulled some stuff out. And then they would build their instrument measurement package, and the churn on this would be 45 minutes, and the whole build time is 90 minutes, but they're only doing this once in a while. This is the thing they can churn on, and they can churn on this back at their old 45-minute rate. That's a time equivalent of John's my distribution installer is a gig, right? His issue was like the file size was too big to distribute. It's actually a similar problem. Just a different, the figure of merit changed. It went from time to size in John's case. This customer, because we were doing this, had taken their first step from monolithic application that I roll out as just one thing to something that has separate packages that are separate units that get worked on separately. So why packages? Why the package as a concept? And sort of what is a package? As our applications grow in size and complexity, there develops a need for a variety of different reasons. Sometimes it's build related, sometimes it's release related, sometimes it's related to unit of work. Some kind of higher level organization. We want those modules, right? Those software modules. And that's what packages are all about, okay? So we start grouping our code into packages, and we get two benefits. The first is that we can start thinking about our design at some higher level of abstraction. And we tend to want to do this with functional requirements. There's actually reasons not to think about it functionally, but in terms of its internal structure, I'll get into that. But thinking about it at this higher level, we're talking about relationships between packages, which is package coupling, okay? And then the other thing we can look at is how do we manage, going back to our customers in John's example, how do we manage development and distribution of software in a way that keeps us sane and on schedule. And that goes to what is in our packages, package cohesion. Okay? And Robert Martin in his book, much like we have the solid principles, there's actually a set of principles that goes along with our package design. This is not hard and fast rules because you're going to make a lot of judgment calls. Okay? This is guidance. These are things to think about. Okay? On the subject of package cohesion, we have 3 principles. I will go into each of these in turn. And then we also have 3 more principles that govern package coupling. We will start with what goes in our packages. I write almost exclusively OO code. That's a choice that I made a long time ago. I know your mileage may vary. Still, a lot of you users not working with classes. Hopefully you're writing coherent modules, APIs, right? Here's a library of VIs that are related. So you're doing the same kind of work, right? Those code artifacts, classes, libraries, sets of APIs, those are great at the tactical functional level. I write a class that does a thing, right? I do a thing, solves a problem, some aspect of my system that it needs to do. Those are great. Packages, though, the higher level is what classes. I'm going to talk about this in classes. If you're not using classes, think about your code libraries. What classes go into that box? That's what package cohesion is about. And this is talked about in terms of reusability. It could be reuse, like I want to give you a piece of code that you can work with. I'm on your development team. I do some work, I give it to you. You apply it to what you're doing, or we share it in the community. It can also apply, as you'll see, it applies to our deployment and rollout issues. We only get there if we do some sort of tracking. There's an implied contract. If I'm going to give you a module that does a thing, you don't want to have to worry about what's in it. I mean, it's not reuse code if you have to care. If it breaks, you don't want to have to drill into it to figure out what's wrong. You want to poke my belly button and say, Alan, you need to fix this thing because it's a piece of junk, and you need to know that I'm going to get on it. And then I have to have accountability back to you for having done that. Okay? And so I have to make a commitment to you to get you to use my package, to get you to use my piece of reuse code. I have to make a commitment to do things like versioning. Here's version 1.1 of my package. It is better than 1.0 because I fixed these 5 things you told me were broken. Okay? I better give you a way that'll roll it back, because if I give you 1.1 and I introduced a memory leak, you need to be able to, you can't wait for me to fix that to keep doing your work. You need to be able to roll back to 1.0 so that you can continue your work while I clean up my mess. Okay? I live in a dark world. What can I say? And so really, honestly, a package at that base level, by the way, this is why we have VI Package Manager, right? VI Package Manager is a utility that does this for us and does it fabulously. It's not the only tool we have at this point, but it's where we started. It's one I use, like I said, all the time. Okay? But that's where we start, as the basic definition of package is something that I'm willing to do that clerical and support work on so that you can trust it, because it is about trust. Okay? I'm offering you this contract, and you use my stuff on the condition and assumption that I will honor that contract. Okay? And that actually leads us to our first principle in our set of 6 principles, which is the reuse, release, equivalency principle. The granule of reuse is the granule of release. I'm releasing a thing to you, and I expect you, that is the thing I expect you to use. And it's really kind of a basic definition. Almost, what do I do with this? Well, it matters later, as you'll see. This comes with a couple of assumptions. One of them, of course, is that I'm delivering something to you that you, my audience, wishes to use. Okay? And the stuff in there should be on theme. We talk about, I'm teaching, my intern and a couple other folks this, and I've said to them recently, you write a VI, the VI does a thing, right? You should be able to express what it does in a sentence or two. Same with a class or a library. Same with a package. What's this package about? And it's a thing that you care about, not necessarily a thing I care about, but a thing that you guys care about. Otherwise, why would you use it? Okay? Everything in that package should be on that theme. whatever that theme is, okay? And so you, my broad audience, when you use my package, you're using it for that same thing. There shouldn't be anything else in there, okay? I am not, I'm here, just give you the example, right? This is actually an example of a package. This is a real world one. You can download this. It's on the NI Tools network. It's the network endpoint package. Manages communication between actors running on different computers. That's what it's for. It's a package. Everything in there is stuff. It all answers that one question. How does this actor tree on this computer talk to this actor tree on this computer? That's its job. Each of you that downloads it is using it hopefully for that purpose. Okay? And there's nothing else in here. I did not ship. The package does not include my suite of unit tests, because you, the end user, don't care about that. You're not going to reuse my unit tests because you don't care about the unit testing. Okay? So, basic definition of a package. Let's go back to that case study. And here it is. We pull out that instrument measurement package, and like almost immediately the first thing that's going to happen is we're going to go, oh my goodness, stuff in here depends on stuff in the executable, and we can't have that, right? We cannot write this so that it depends on a library that's in here that's commonly shared. We actually have to pull that stuff out into another package. That's the way the executables work. Okay, so you pull that stuff out of there, and we realize real quick, all right, instrument measurements relying on calibration stuff, right? There's a calibration set of APIs for managing instrument calibration, which has records and puts things in the database. And this is all stuff that's common to these guys, so now we've got a whole separate package. Well, that's a lot of stuff to put in there. And if this is the very first thing you do, right? Okay, right? I can actually see that. We'll build this as a PPL, and we'll have this as a PPL, and we'll build this executable. And that's a fine place to start. But you're going to find that you're poking this kind of a lot because you've got 3 different things in there that's going on. And that leads us to our second principle, common closure. Classes in a package should be closed together against the same kinds of changes. And a change that affects a package affects all the classes in the package. Right? So that common closure tends to drive stuff out of that one package into more packages, where each one of them has a smaller, if you go back to that what's the granular reuse, right? Smaller, more tightly focused packages that if I'm changing how I do calibration in my system, hopefully I'm only touching this, and it's pretty big. If I change the database, that's kind of going to change a bunch of stuff, but calibration maybe doesn't affect this if I make that change. And this particular case study is probably not the best representation of common closure, but the idea is common closure is going to make us want to take some things apart and group them not by functionality. That's actually the failure here. We're going to group them by when they're going to get changed, when they're going to get worked. This is the stuff that all has to change together for some reason. If I'm changing one thing in here, I'm going to probably have to change all of it, and hopefully not somewhere else. I want to keep that to a minimum. So going back to this guy, there is an argument because of common closure to say, well, this is my core stuff, and this all is going to change together because this is how I move a message from the actor tree and turn it into something that I can broadcast out across the network. But maybe the specific implementations, TCP/IP, network streams, maybe those should come out, because I might change how I want to do TCP, and I want to change that without necessarily making somebody reuse this, because the guy who's using network streams doesn't care about my TCP change. Here's another example. This is a failed CLA exam. For those of you who don't know, I wrote the Actor Framework course, led me working really closely with people in Custod, and that also led me to helping them grade CLA exams that used Actor Framework, how to teach them how to do that. This is nobody's real CLA exam. Okay, I'm not a jerk. This is an example based on several things that Nathaniel and I saw. That's like, we don't like that. We're gonna take some points off of this guy because of some things we didn't like to see. So this is again kind of a composite, no specific individual. This person wrote out his CLA exam, and he was thinking about packages, his groupings. The exam typically says, you're going to have, and actually the CLD does this as well, you're going to write some stuff, you're going to talk to simulators. And then the requirement is that you can write it in such a way that it's really obvious how to swap the simulators out for hardware. Okay, so he said, all right, cool. I will have my core and my console and my IO library. And I will group them together in this fashion because this is the stuff that I'm actually delivering, and this is where I put all my simulators and stuff. But also my live code. What do you think of this? What do you think of this organization? Go ahead.
I don't like that the simulators and the real hardware are on the same library. Separate libraries. You make them plug in, you want them.
Gold star to that man, or whatever we have for prizes. Toss that man a GDevCon pen.
I would also think so, not just pulling the simulator out, but you also want to separate the interface from the actual hardware as well.
I will get to that.
Okay.
That's actually a separate point a little bit later. Hold on to that thought.
Okay.
But the point I want to get to right now is, what's your name, sir? Mike. What Mike brought up is this. You can make an argument that's so far so good, right? We've got, here, this is the reuse thing, and I'm going to give you that, and I'm going to give you console stuff. You can make an argument for, REP, reuse, release equivalence, right? You can make an argument for common closure because you could say, if I change my IO changes, right? If I'm changing these messages, that's going to change all this stuff. But as Mike observed, that's not really what we want to do because the packages are not, the stuff in the package should be reused together. This is the common-reuse principle. Classes in a package are reused together. If you reuse one, you reuse them all. A little illustration of this, right? I got package Y, I got package I. And package Y has some classes in it that depend on this guy, but not these guys. They're off doing something else. Now, again, think about that churn. Think about if I make a change to this, any change to this, I am forcing on this user, which may cause him to recompile, at least is going to have to cause him to revalidate his code, right? That's non-trivial. So he really doesn't want me messing around with these because he doesn't care. So those need to come out. Common reuse says those come out. Classes in a package are going to be more tightly coupled, possibly very tightly coupled, than other things in your system. I will actually call on Hope's example from earlier. God, I love you guys for giving me all of these live, real-time, recent things that I can talk about because a package in Hope's system is going to be the temperature sensor, the configuration token that goes with it, and the UGUI that goes with it, because those are all going to change together, and you don't want to change in one to drive a change across the package. Okay? These three principles argue with each other like an old married couple. Okay? They're constantly pulling, or like Norman Darren, right? They're constantly pulling on each other, or a bunch of architects at a summit. They're all constantly pulling on each other, and it is a rare day when you're going to get complete alignment where you go, yes, that all goes in the package, and we've satisfied all three of these things. Yay, us. Ain't gonna happen. What you're gonna do is you're gonna strike a balance. And this is where your judgment calls as professionals come into play. And by the way, you're going to adjust this over time as your needs change the software, right? But you're making that balance between these things all go together. But again, I have to have some packages of some size, so I don't want to have 472,000 packages because that defeats the purpose. I need to really only have, some smaller number. But I have to decide what goes in and out. Okay? Go back to this. This tension is actually why I decided that, no, I think for the package delivery, I'm going to go ahead and put the TCP stream and the network stream in, even though the changes here would drive a change to the whole package and force you to reuse it. And my argument behind that was, well, these are 90% use case, 95% use case. almost always, if you're doing this, you're going to use one of these. The package is extensible to allow for testing, for example, but I certainly don't want to ship that to you. Or somebody's using this to do a UDP broadcast. You may not want to do that, right? You could put anything in here. You could put CAN bus in there for all I care, right? And then of course there's this. I had to do this. I'm actually going to be talking about this at the GLA Summit. I had a customer that wanted to change how messages were flattened. And I guarantee that almost all of you do not care about that, but this one customer did. So I'm certainly not shipping that to everybody, right? So those do not go, those become separate packages. Stephen is nodding with a look on his face like he's had to deal with this particular lemon before. Okay, so that's package cohesion. You're balancing these out, you're constantly making these assessments. Common closure, common reuse are going to tend to drive you to smaller packages, but for your sanity, you're going to make judgment calls and you're going to have them be a little bit larger based on your personal likely vectors of change, which are not necessarily mine. All right, so let's move on to package coupling. How am I doing for time? Oh, okay, I'm about 30 minutes in. Ooh, I better hustle. Package coupling. How our packages talk to, what is the relationship between our packages? Hypothetical application of a fairly large size, and this is the relationship between the various packages that I have defined, that I've gone through and applied my cohesion principles to, and I've got some pretty good packages. All right. My relationship arrows. This is an arrow of dependency, so my task depends on database, for example. Okay, and my arrows flow in a good, reasonable, manageable direction. I have a few packages that if I change them, I'm going to drive change to the whole system. That's going to be true. But my tasks can do his work and not mess up the gal that's working on message window. Okay? She's not going to have to worry that I'm going to come in and make a change here and make her work late because I broke something over here. That's a bad thing to do. And that's great. And then the new guy comes in and he makes a change to my dialogues and my apps, by the way, before we did this, my apps is awesome. Anybody could come in and jerk around with my apps and not break a single thing in the system that wasn't in that package, right? That's what we want. And then somebody comes in and breaks it, adds something in my dialogues that links back to something in my app, and all of that goes out the window. Okay? Yeah, it's party time, right? You're all staying late we're having a big party staying late at the shop. Because now, if I change my tasks, my intern is going to be staying late because I just broke my window as well, because it all circles back on itself. We're back to a monolithic thing that can really only be delivered as a single entity. And at the risk of, since I wasn't there, I only observed this from the outside, but that's my understanding of why LabVIEW 8 was so hard to deliver, because they had about 8 things at a core level that all depended on each other. And so they couldn't, if they changed, someone would change one thing and completely break and have to, what happened over here, and they'd have to rework it. And that's why LabVIEW 8 was so long out the door, and why we spent a couple of years sorting out what happened after that. So that leads us to the Acyclic Dependencies Principle, which says, allow no cycles in the package dependency graph. What I just showed you is a package dependency graph. Restated, the dependency structure for the package must be a directed acyclic graph. Huh? What the heck is that? Okay. So this is a directed graph. It has nodes. It has edges. Edges have directions. And the rule is that you should not you can start at any one of these, and it should not be possible for you to do this and loop back to where you started. So this is a cyclic graph, and this is terrible, and we can't allow that. It has to be acyclic. We have to. If this shows up in your code, well, here, I'll take the arrow out. If this shows up in your code, you need to fix that immediately. That bubbles up to the top of your list of things to fix, okay? Because otherwise, you're all going to be staying late. Just order the pizza. Use Norms. Norm, does your order pizza thing from LabVIEW still work? All right. If you do this, download that because you're staying late. Okay. So don't do that. Don't do that. How do we break that? Now, here are a couple of actual practical tools that I'm going to put in your toolbox because I do these things all the time. They came up in active framework development. It's actually how we wound up with abstract messages. So 2 ways to break a dependency cycle. The first is dependency inversion, and then the second is to make a new package. Okay, so here we go. My dialogues depends on something in my app. Really have to have a chat with the intern about this. Class X now depends on class Y. That's the thing that's driving the dependency direction I don't want. How do we change that? Find the methods of class Y that class X needs to call. Put those into an interface or abstract parent. Okay, make them dynamic dispatch. And then make class Y inherit from class IY and implement the specific behavior that you care about. And then class IY goes into the package. Basic rule. Things like interfaces belong to the client, the entity that calls them, not the things that inherit from them. Okay? Class X wants to call things. This is how class X wants to talk to the world. And so it belongs to class X. The other thing you could do is to make a new package. Right? So in this particular case, the problem with my dialogues is it depended on this class Y that lives in my app. Well, if it's that simple, just make a new package. Pull class Y into a new package. It can have one class in it. It's okay. You're going to have more. You're going to add to this package. I guarantee it. And pull class Y out and stick it in a new package. And there you go. Everything is fixed. Everything is cured. By the way, for those of you who do active framework, this is abstract messages right here. Okay? And this is closer to interfaces and how interfaces solve the talking to your caller problem in active framework. I say closer to because you wind up with a little bit of dependency inversion because you do actually have to put an interface in with the message classes. It's okay. All right. So,
Alan,
yeah.
is it okay if I ask a question?
Yeah, briefly.
Okay. You're couching this all in terms of classes, which is appropriate, which is all that you do. But I think there's a real key point that I'd hate to have missed. Type defs. Type defs are so much more innocuous than the class. You're getting there? Okay.
No, I wasn't going to mention type defs specifically, but go ahead and finish your thought, and then I'll have my thought on type defs.
Just because all of us that aren't doing tons of this might not apply to me, but that idea of, no, that very thing, like having a package or a library just of type defs outside of your library is such a huge thing because it causes that thing. So, for those of you who are not folks,
do that. Just do that. Worst thing in the world you can do is to put a type def into a class that something outside the class is going to use. Okay, don't do that. I'm going to pick on this guy. I'm not going to name who it was. But one of the things that drove my hypothetical example was I got here, this project takes 20 minutes to load. And I loaded the project up, and sure enough, it took 20 minutes. And it took 20 minutes because the guy had taken all of his libraries and put them in libraries. And if the libraries in libraries, and if the libraries in libraries, and then had one master library that had all in it, and at the top was a type def. And when I tried to load that type def, it was taking 20 minutes to load everything. As soon as I broke out that first library, he was down to a minute. And then we went and broke it down further. And we had a long conversation about, and this was before I really studied package design, but we had a long conversation with that customer about libraries pulling stuff in and when they're supposed to get used. Even my daughter is just wincing in horror at this. I'm sorry? Yeah. Right. Okay, so that brings us to something that you have to kind of go through the steps to see about package design, which is that package design is software engineering, not software design. Okay? Your package design is going to evolve with the application. You saw it. We're moving classes around between our packages. We're making new packages classes to resolve those cyclic dependencies. Okay? You will move your classes around between and into new packages as your software grows in complexity, as you add functionality, as you come to realize that the things your classes need to do have changed. This jitter is normal and appropriate, And you can't, this is why your packages are not functional decomposition. You cannot define in advance what is going to go into your packages because you actually have to have some classes first and see how they interact to figure out what your package design needs to be. Okay, there is no top-down package design. Package design is not functional decomposition. Because of that, functional decomposition you can do in advance. You know, that's a first order. It is a map to building your software. That's what this is. This is how I take my software and put it together and push it out to the world. If you go back, I'm going to go back. I really need to, let's look at this guy, right? If you had to build all of these out of PPLs, what PPLs are you building first? These guys. You're going to build those, and then you can build these, and then you can build the complete application. So if you think about it in terms of a bunch of Jenkins or GitLab steps, you're going to have several steps, and you're going to start with these guys and build up. I think that tripped up a lot of people with their PPL designs at first. There's too many cycles, and we actually have a problem with that in the actor framework with the AF debug library because they're mutually dependent. Yeah, there you go. The other thing you, hopefully, some of you may have noticed is that there is actually, I'm going through these in the order that I'm taking these on in this order because there is an order to them. When you first start off writing your application, you have no classes or libraries or type defs, as Norm brought up. So you don't have any code to build, so there's no need for a build map. Then you go, I've gotten a certain size, I got to pull that instrument measurement library out, and that means I've got these other packages now that I have to build as well. And so you start to care about package cohesion, starting with how many packages am I willing to support. Like I said, that very first pull the instrument measurement library out, and then all the subpieces into a single package. That's not where you're going to end up, but it's not a bad place to start, honestly, just to get your feet wet. That's reuse, release. I only want a couple of packages right now. Then you're going to care about common closure and common reuse. As you work stuff and you find out, God, if I work on this package, Darren's going to hate me because he's going to have to change things. So maybe we can move our stuff around, change our responsibilities. And then someone comes in and writes that first cycle into your code, and all of a sudden you care about package coupling. Okay? And then from that, we get into our two stability-related principles, stable dependencies, stable abstractions, and I will go into those. But first, I have to tell you what I mean about stability in this case, because I'm not talking about churn on the code itself. I'm talking about really how hard it is to change the package. That's the thing that matters here. We'll go back to my failed CLA exam. Project on the right, class diagram on or it's my right. Package is, stage right, your left. A class diagram over here on the right. Was it you that mentioned the interfaces? Somebody in the room mentioned the interfaces were in the wrong place. Sam mentioned that. This is where we're going to get into that, okay? So we're looking at this and we're like, okay, what's going on here? And the idea behind stability here is a little bit different. Robert Martin makes, the analogy of stability like a table. Okay, I got a bunch of stuff on the table. The table itself may be rickety and about to collapse, but if I flip that table over and I spill beverages everywhere and I break computers, that's the real problem. The table is stable because I want it to be, I need it to be, not because it actually is. So here's an example. Here's an example of a stable package. This is X, and we say things like X is responsible to these packages because it exposes some behavior that these guys care about. X is independent. It doesn't depend on anything else, right? We can make changes to it without relying on something else, and therefore X is stable. If I make a change to X, I am probably going to push that change out to the other packages. And so, don't want to touch that. Contrast this with Y, which depends on everything else, is dependent on everything else, and I can do whatever the hell I want with that because you aren't going to be affected, right? We can change this pretty much at will. This is instable. This is strictly a John McBee analogy, but it is great. He had the idea, like we were about to give this presentation, and he like had the inspiration in the middle of the night and ran out and found a Jenga board just so he could do the example. And then coincidentally that NI week, Perkins Coie had this big Jenga board, Jenga set up down on the floor. It was great. Timing couldn't have been better. So everybody know how to play? Does anybody not know how to play Jenga? Cool, don't have to go into the Jenga rules. Fair to say that the direction, if each of these is a box of code, right? And this code is all of comparable quality, and we kind of like it and we're good with it. Fair to say that the dependency goes down, right? Okay, right. The guy at the top is the unstable package. I can pull blocks off the top all day and I can not knock the structure over. This is a whole lot less true for this one guy at the bottom, right? Okay, that's a stable package. Which one do you want to work on? Come make a change. You need to make a change, and you're responsible for what happens in that change. And my daughter is gesticulating wildly that this is the one she wants to work on. Okay? That's the definition of stability. The stuff that we really would rather not change because of the technical debt we're going to incur by making that change. Okay? Depend in the direction of stability. This is the Stable-Dependencies Principle. Change is inevitable in our software. Stephen once told me that software that isn't changing is dead. I think it's a fair observation. Some of our packages are going to need to be unstable. Hope's instrument libraries, right? We're writing new instruments all the time. We're tweaking those. Those need to change. Those go into unstable packages, stuff that nobody else is depending on, as best you can. Reality always intervenes. What goes into the stable, non-volatile packages? The stuff, your high-level architecture, your business rules, the stuff that the purpose behind the software goes there, because that's not going to, hopefully, not going to change, in your time frame. We can measure stability. Here are some metrics, and it is a ratio between what classes depend on stuff inside my packages and then what inside my packages depends on stuff out. And we can define this ratio of instability. Now let's go back to the failed CLA exam and Sam's observation that the interfaces are in the wrong place. If we do the calculations on these classes, we find that we get an I of 1 for the controller, maximally unstable. Console metrics, console, maximally stable, I of 0. This is exactly not what we want. This is the antithesis of what we want, because this is the things that are going to change, right? We're going to be adding new hardware. We're going to be changing possibly some of these rules and stuff. And this is our business rules. This is the stuff that we want to write once. We don't want, you've seen this. I need to put in new hardware and you're changing your business rule stuff. It's terrible. Okay? You look really closely, and as Sam stated, it's their fault. Well, it's the package designer's fault. These are in the wrong place. If I whip out a little dependency inversion and pop those two interfaces up into the core code, as you'll see in just a second, the numbers get a lot better. Stable dependency is, stable dependency is you depend in the direction of stability. Stable abstractions says a stable package, we're going to be successful in having stable packages if they are abstract so that we can extend them without changing them. This is closed to modification, open to extension. I can add new consoles and not change this. That's what I want. Okay? A package should be as abstract as it is stable, because it's not either or. There's going to be a continuum. I'll talk about the continuum in a minute. Ooh, running out of time. These two work together. Stable dependency, dependencies flow in the direction of stability, and your stable stuff really needs to be abstract. And so dependencies run in the direction of abstraction. Again, with the metrics, simple ratio. Number of classes in the package to number of abstract classes in the package. What's an abstract class in LabVIEW? For our purposes here, we will count an abstract class as anything that has at least one abstract method that you need to inherit from this thing and replace it. We'll go with that. For our purposes, it suffices completely. Let's go apply those metrics. This is the original one. This is the one with the terrible instability numbers. And if we go and apply our abstraction number, we see that this is the problem. This has no abstractions. All the abstractions are down here, right? An abstraction value. The same change that I showed you, and it will not always be true that it works out this way. Our simple example, this works out. You see that now we make that change, our instability numbers get better, and really honestly, it's because our abstraction numbers got better too. Okay? Going back to network endpoints. Actually, this is the CLA exam again. So this is what you wind up with when you're done. This is my core. This is my business rules, including, because this is what interfaces do for us, how does the controller want to talk to the rest of the world? Okay? These are the messages it wants to send. These are the VIs it wants to invoke. And then these guys are the answer to that, and these are our concrete implementations. Robert Martin talks about deferring details like hardware, because hardware is a detail. It really is. I mean, hardware changes the life of a project. It's not your core business rules. But this is how you push those details off as long as possible. This is the stuff that really shouldn't be changing. This is the stuff that can change pretty arbitrarily. And then I went back and applied the cohesion rules. And while it probably makes sense to have all the simulator stuff go together, because the testers want that. Here's your tester package. We probably want to actually split up the console and I/O packages from each other. And these show single classes, but they'll really be like the whole host of classes that go to that. Okay, last few minutes before I get dragged off the stage bodily. We love us some numbers. We have metrics, we have instability, we have abstraction as calculatable values. We can plot them. Probably not relevant for small to mid-sized projects, but when the projects get really big, it starts to make sense to do this, right? We can have instability on one axis, abstraction on another. We can define, this as the mean, sort of how the two work together. We really want our stuff to fall on this, and we can actually define how far things are from this value. And you can see that from our CLA exam, once we've done the appropriate work, core's kind of up in here. It's not perfect. Things up here are ultimately abstract and ultimately stable, right? This is the stuff that is never going to change because we don't need it to, because it's our business rules, right? All the way down here is going to be stuff like hardware calls that is subject to change, that we want to be able to change often because of reality. And stuff ideally will fall along here. It's never going to be perfect, but you want to be kind of close to this line, and you can measure that distance. All the way down here, maximally stable, minimally abstract. This is stuff that is likely going to have to change, and oh boy, do you not want it to. This is the zone of pain. If you're not careful with your database schemas and don't isolate them properly, they can drive error stuff, right? Can drive your entire package if it changes. We can't change the error cluster even though we want to because we've relied on it for 40 years. Okay, kind of stuck. We'd like to change it, can't really do it. Now, some of the string libraries, they're well understood and perfectly defined and nobody cares, right? So there's a few things that can be on here. Most of the time you want to stay out of here. All the way up here, maximally abstract and nobody depends on it. Why is this stuff in your code? Zone of irrelevance, right? Zone of uselessness. Don't have stuff up there if you could avoid it. I mentioned that packages are subject to jitter and that's expected and appropriate, and you want to take advantage of that. We can take a snapshot of our current application and see where we are. We can look at the health of a single package over its lifespan with that D prime, how far we are off that ideal center line. And we can put control limits on that. And when we, over time, so this is maybe every sprint we go and we do this calculation, right? Or whatever. And you pop up outside of that, maybe we should look at fixing that. Okay? Now, doing this math, like I said, on a small to mid-sized project, you can probably eyeball it. Larger projects, some folks start to do this. And my co-author, who isn't here, wrote a tool to do this math for you. I don't think he's maintained it in a while, but you can go check it out. And if you need something, you can probably poke John, and he might do it for you. Might. Okay, so that's it. That's the principles of package design. They are this high level of organization, and it really is about how do I make it so that I can work on my software effectively, separate stuff so that people can work on portions of the code and not really screw somebody else over in the organization, right? That's what that's about. How do we roll it out and deliver it? Whether it's reuse code for a neighbor or a complete application. We can measure coupling, okay? Our package design is bottom up. Can't stress that more than enough, right? You're not designing your packages up front. They might have an idea, but that idea is going to be very subject to change. And they're going to evolve over time, and that's okay. Your packages are your basic unit of work. Honestly, your packages can and probably will have different development cycles. That's okay. That's appropriate. And it is a build map for your application. Go read Robert Martin's works. Agile Software Development is a great book. You should read it for lots and lots of reasons. I'm still digesting clean architecture. And here is how to find us. That's me on the left. John's not here, but I'll give him a shout out on the right. Go find me on LinkedIn. Tell me you saw me at the GDevCon conference. I'd love to hear from you guys. And Mom, how much time do I have left? 5 minutes. Got 5 minutes for questions. Mike. Give Mike the mic.
So this is a question for you, Alan, but also open to anyone else in the room. What I really wanted is something that will like warn me and slap me on the wrist immediately if I accidentally introduce a circular dependency. And I would accept it as a VI analyzer test. I'll accept it as a scripting tool or as something that is watching me live as I develop, and every time I do it, it yells at me. I'd want that. It would be nice if I could call it as a Jenkins rule every time, my team of developers commits their code. At night it runs, and it's like if some developer C has done that, it yells at them, shoots them an email. Does anyone have a... Yeah.
Have you tried using anti-doc? I use that quite often, and it definitely works for DQMH modules to show you the dependencies and cycles. And it's extensible, and you could potentially write a plugin for Actor Framework. Oh. And I think it just does classes too in general, so it's worth looking at. It's very simple and easy to set up and free.
I will check that out. Haven't checked. Okay. So look, hey, tools to support our architecture efforts. Excellent. Anything else? I put you all to sleep.
Hey, Alan, you started this talking about JKI package manager and how that was the original right here, the original driver of this. But now, as you went on, it seemed like you were talking more about library design. Could you talk about the difference between distributing packages versus creating libraries? Is there a difference?
So I mostly work on Actor Framework, and when I've been thinking about this, I've been thinking about the library of an actor, which is a package, right? It's a self-contained entity. I think that. So we talked about our. So it's a good question.
How about network endpoints? That's more than a single library in there, but you're calling that a package.
Yeah, because they go together. They logically go together. So network endpoints, you don't use network endpoints directly. It's actually an abstract class. The caller and nested endpoints, in any given system, you're going to use those in combination. I don't see who's on my mic? Okay, thank you. I'm staring off at that guy and I should be addressing you. So that's an instance where, you might have, a package might be a library, but I think your package can contain several libraries. But the libraries are intended to work together as they are in the network endpoint package because it's a base class, it's an abstract parent, 2 children, and then the classes that make up, that are used by either the abstract parent or the children. So they are tightly coupled. They're supposed to work together. My argument about the message streams coming out is because they're coupled through an interface, so they could come out. It really is that you go back to those cohesion rules. How many packages are you willing to support? Is the stuff in that package, is it all supposed to go together? If you change one part of it, can you expect another part of it to change? Do they change in the same way? And you're balancing those 3 rules. So, if you're distributing an instrument driver and you're not using classes and you put it into a library and it's the VIs that go in that library and maybe there are a couple of sub-libraries, okay, that's going to be a package because you're on a single theme and that stuff changes together and you want that to be a separate, and you only want the instrument driver stuff in there. Network endpoints has more stuff. Hope's package for managing configuration. Excuse me, it's getting late in the day. That kind of makes sense to go together. What do you expect to go together and never separately? And never's a strong word, because the ideals are, we're talking ideals here. Your package will have one or more libraries, I guess, is probably a fair way to answer your question. Does that help? I mean, these are design considerations. You got to think about this and apply it to your work.
I'm thinking of like maybe I'm thinking of an edge case, but say either what Norm was talking about with type defs in a library, or say a library of just interfaces that you may reuse across other packages. And how would you go about packaging a smaller library that's going to need maybe a package of package or?
So I would see. So I see my type defs as like sort of fundamental to the application, because they are something that winds up going across several entities. It's going to be something you're not going to change much. I mean, we make them type defs so they can change them easily, but when you change them, you affect so many other things in your application. I've always thought of them as just foundation. I don't even put them in a library. My type defs they're in a virtual folder in my projects because you can make some weird dependencies by pulling your type defs together. Things you don't want, right? My guy with the 417 libraries and one type def. And because he had that one type def and he grouped it with everything else, he had the 20-minute load time. Packages are good for reducing load time, by the way. And I think I'm getting the big crook to drag me off stage. Do we have time for one more question, or are we done?
I think we're done.
Okay.
Alan obviously has lots to say about this, so catch up with him if you have more questions. Thank you very much, Alan.
I saw Stephen taking notes. I'm sure I'm going to hear about it.